Welcome to 55, piecewise linear functions. We're going to be building some linear functions, writing the equations of lines that describe various situations. Actually, we're going to focus a lot on cost structures, which is a very common application of these straight line functions. But first, let's kind of warm up, bring some stuff back to memory. You know that 2 points defines, I should probably cross off the S. 2 points make a line. So if I give you 2 points, like here's 2 points. If I give you 2 points, it should define a single line, which means you should be able to find an equation that describes the line. So let's just kind of, let's see. I know you've done this before, but let's try to remember how this goes. So first I'm going to take these improper fractions and convert them to mixed numbers just so I know how big they are. So 3/2. 2 goes into 3 once with 1 left. So that's 1 1/2. 17 over 8. 8 goes into 17 twice with 1 left. So that's 2 1/8. Okay, so that's my point 1. I'll call that point 1. Here's my point 2. Let's see. 9 over 2. 2 goes into 9, 4 with 1 left. So that's a 4 1/2, and that's a 4. Okay, there's my 2 points. Looks like I'm entirely in the first quadrant because everything's positive. And it looks like I need my XY axes to go just up beyond 4, so maybe 5. 1, 2, 3, 4, 5. Might as well be more or less to scale, right? Okay, so where are these points? The first point is that x is 1 1/2, y is 2 1/8, somewhere around there. I'm going to call that my, I suppose I could label it 1 1/2, but I'm going to call it my point x1. In fact, I'm going to use another color real quick. Like. So 1 1/2, 2 1/8, yeah. There's like my first x coordinate. That would be this one is x1. And it has a y coordinate, so to speak, of 2 1/8, which I'm not going to call y. I'm going to call this f of x1. Right? You plug in x1, you get out f of x1. That's the output. So this is kind of like my x-axis, and this is kind of like my f of x. It gets plotted along this axis. So anyway, remember the part, I've said this before, y, or I should say f of x is like a glorified y, so to speak. That's speaking roughly. But in lots of places where we used to write y, we just start writing f of x, and it's worth getting used to. Anyway, here's our other point. I'm going to call this my x sub 2. It's at 4 1/2. 1, 2, 3, 4 1/2, which is right about there. That's my x sub 2. And how high do I go? My f of x2 is 4, so I go up to 4. 1, 2, 3, somewhere around here. So that's my f of x2. Okay, so I got these 2 points, and what I want is I want the equation of the line that goes through those 2 points. Now you remember what we're going to need to do here. We're going to need to get a slope and an intercept. Remember the old slope-intercept form? That's what we want to do. We used to write y equals mx plus b, but we're talking linear functions, so if you don't mind, I'll write f of x equals mx plus b. This is what we want. So I'm going to need the slope. Fortunately, slope, there's a formula for slope. Remember, slope is interpreted as rise over run. The rise is basically, you're looking at going from this point up to this point. And notice the rise is basically subtract your 2 y coordinates there. Take the f of x2 and subtract the f of x1. That'll give you your rise. And then the run is this way. And how do I get that? I subtract the x2 minus the x1. I mean, yep, if you were counting squares, you'd be counting along here somewhere. So let's put the numbers in. F of x2, I got that right there. It's a 4. Ooh, it's really supposed to be a 4. Minus the f of x1, which is over here. It's a 2 1/8. Over, and then you take the x2, which is the 4 1/2, minus the x1, which is the 1 1/2. Huh, not bad. Okay, so in order to do this, let's come back over to here someplace. I'm going to call that 4 a 4 over 1, because I'm getting ready to play with fractions here. That 2 1/8, I'm going to turn that back into an improper fraction. So 8 times 2 is 16 plus 1 is 17. So that's a 17/8. That's on top. On the bottom, I can do that subtraction right now. 4 1/2, take away 1 1/2. That'd be a 3, wouldn't it? That's just a 3. So on the top, well, how do I do this? Well, I need to make sure I do the old common denominator thing. So I need to multiply this by 8 over 8. 8/8 is 1, of course. So all it does is change what the fraction looks like. It doesn't change its actual value. So this will be a 32/8 minus a 17/8 all over 3. So 32 take away 17, is that 15, I want to say? Yep. 15/8 over 3. Now, that's a too tall fraction, right? That's no good. Remember how to unstack a fraction. You turn it back into a division. That's what the fraction bars mean. They mean to divide. I know you know this. If I had a 6 over 2, you wouldn't hesitate to call that a 3, would you? 6 divided by 2 is 3. So the fraction, whoops, so the, I really don't like the way they rearranged the eraser on this thing. Anywho, you turn it into a division is what I was saying. So you take the top fraction, 15/8, and you divide it by a 3. In order to do that, in order to divide, you multiply by the reciprocal. Remember this idea? And then remember this idea. Whenever you're multiplying, look to cross cancel first. You don't only do that with multiplying, but as long as you're multiplying anyway, always check to see if you can cross cancel. Because if you can, it'll make your life easier. If you don't, you're going to end up with big numbers and then you're going to have to reduce, and it's a task. Who wants a task like that? Well, I got the m. Woohoo! So remember what I was saying? F of x has to be mx plus b. Well, I know what the m is. So I'm going to put a big, so f of x is, the m is 5/8. Woohoo! X plus b. All right, I got to figure out what that b is. How am I going to find the b? How the heck am I going to find the b? First thing I'm going to do is I'm going to change colors. I'm going to go back to blue. I like blue. Change colors. And I'm going to actually write this out. How to find b. Because a lot of times when you say something or even when you hear something said, it sort of goes in so tentatively. But when you write it out, and not just see it written out, but when you write it out yourself, somehow it helps it go in better. That's what I find anyway, as long as you make it a point to understand everything you write. So I'm going to write this out. So we know, what do we know? We know that, okay, see this line up here? What are we trying to do? We're trying to find the equation of the line. And what does that mean? It means that every point on this line will satisfy whatever the equation is. Right? The equation of the line, every point on the line. I'm so trying to backspace, but it won't let me. Every point on the line has to satisfy that equation. So that's what I was going to say here. We know that every point on the line must satisfy this equation. Now, we haven't finished writing the equation yet, but whatever it is, whatever that b is, every point on the line must satisfy this equation. You know what else we know? We know the coordinates of not just one, but we already know the coordinates of 2 points that are on that line. These 2 points are on the line. I'm just going to grab the one on the right, the 9/2, comma 4. We also know that the point 9/2, comma 4 is on the line. This is called a syllogism. This, that, therefore, blah. We know every point must satisfy the equation. We also know that that point is on the line. Therefore, by the way, 3 dots in a triangle means therefore. It's a beautiful abbreviation, whoever came up with it. It's a lot easier than writing therefore. Anyway, therefore, we know that 9/2, comma 4, or I should say, when we plug in x equals 9/2 in the equation, it will tell us that y is equal to 4. That's the whole idea. Remember how you make an xy table. You plug in x, you get y. Well, we need to be able to plug in x equals 9/2 and get y equals 4. Yeah, on this equation. This is the equation of the line, or it's supposed to be. So when we plug in x equals 9/2, we should get y equals 4. So I'm going to make sure that happens. So here I go. 5/8 times x, x is 9/2, plus the b that I don't know yet is going to be 4. This is how we can get our b. So I'm looking at this fraction and I'm saying, gee whiz, it'd be nice to cross cancel, but apparently we cannot. So straight across, 5 times 9 is 45. That's over 16 plus the b is equal to 4. So what's the b? Well, it's going to be like a 4 over 1. I know I'm going to be playing with fractions, so I might as well make it look like a fraction. Subtracting the 45/16 on both sides. Now, in order to subtract those two things, you must have a common denominator, so you do the old 16 over 16 trick. So what do we got? We got a 64/16 minus a 45/16, which is, let's see, 19 over 16. That's our b. And so now I can finish this, and before I finish this, let me do the old shrink this down trick. Boy, I love being able to do this. Nice way to get rescued. Nice way to get rescued. So here's our finished equation. We know that the m, the coefficient of x, the slope, is 5/8 plus, and now we just solve for the b. We got 19/16. We are so done. There it is. There's the linear function that goes through those 2 points. That's it. And if you want a nice little exercise, so we just used which point? 9/2, 4, right? So we used this point in order to solve for our b. Well, you should be able to plug in this point. That should work too. So if you plug in x equals, let's use the improper fraction form actually. If you plug in x equals 3/2, you should get, so I'll say the exercise is to show that you get y is equal to, what are we supposed to get? We're supposed to get 17/8. Okay. 17/8. And I actually did this to make sure it was working. And it did. And you should do that. Make sure it's working. Especially if you want to, if you want to make sure, I guess. Okay, so that hopefully brings back some happy memories of fitting equations of lines that'll go through 2 given points, right? It's basically find the slope, rise over run. You can use this as a formula if you wish. Basically subtract the y coordinates, subtract the x coordinates, simplify your fractions. And then you'll get to this part, which is missing part of its thing here. Okay, and then that'll enable you to write this much of an equation. You know what the m is, get the b. How do you get the b? You use one of the points. You plug in the x coordinate for one of the points and make sure it gives you the right y coordinate. That'll solve for your b. Works great. So here's the main beef for today, these cost structures. I want to play with cost structures. Why do I want to play with cost structures? Because, well, I guess because they happen a lot. Is that a good enough reason? There's lots of them out there. I also kind of subscribe to this belief, I guess. I was looking at, you're a math teacher. Of course you're going to ask this question. Why should they learn math? And I'll never forget, this guy came up with what I think is probably the best answer I've seen so far. Why do you learn math? Because you live in a society that's mostly free, which means you should be able to handle your money. You need to be able to handle your money, and your money is numbers. And especially if you're going to have a business, you're going to need to be able to handle your costs, or if you just want to analyze your expenditures or whatever. You need to be able to play with costs. And especially these days, everybody uses the Excel spreadsheet. And it's nice if you can plug in formulas and stuff in your Excel spreadsheet. And it turns out for money, you're going to use a lot of straight lines. You're also going to use a lot of what they call exponentials. So today we're doing lines. Later in the course, we're doing exponentials. But anyway, being able to swing these kinds of equations around, you can, especially when it comes to like a mortgage or whatever, you can really be in good shape or better shape when it comes to handling your own finances. Not getting too far in debt, figuring out how to get out of debt, all that good stuff. Anyway, so what are we going to do? We're going to analyze this, okay? So, Biff's Biodiesel Bonanza. It's supposed to be like a store. You can buy biodiesel fuel. And I just looked up the price today, and yeah, it really is around there. Or it was anyway. I think it was like a month ago, something like that. Anyway, you can buy biodiesel for $5.15 per gallon. Okay. We're starting with the simpler example, of course. Write the function c of x C stands for cost. The cost of purchasing X gallons of biodiesel from Biff. Okay. Now this, how should I say this? I'm going to write this down. A constant cost per gallon. That's what kind of characterizes this situation. This is the stuff of linear functions. When you have like something costs this much each, that is a perfect linear function. And you can just kind of start to believe this. If I don't, let's say X is this way, how many gallons did I buy? And this will be the cost going this way. If you don't buy anything, you don't pay anything, right? That makes sense. If you buy some, you pay some, right? That makes sense. And if you buy twice as much, you pay twice as much. And if you buy 3 times as much, you pay 3 times as much, and so on. It's a nice straight line. It's a beautiful straight line. So whenever you have this constant cost per whatever it is you're buying, per gallon in this case, it's going to be a straight line graph. Now here's the big question for you. Q is for question. What is the slope of this line? What's the slope of that line? Can you tell me? Can you figure it out? This is going to be easier than you can imagine. Think back to the alternate, if you saw the co-rec lecture on this, the alternate interpretation of slope is, M is how much y changes when x increases by 1. Now, is that saying the same thing as rise over run? It actually is, because how much y changes, well, that's what the rise means. What we're doing is we're setting the run to 1. So if you know the run is 1, you can just take the rise. How much does the y change when x increases by 1? And that'll be your slope. Okay. And how is this helpful exactly? Because they're telling us the cost per 1 gallon. Get it? If I buy 1 gallon, let's just say that's 1 gallon, X is changing by 1, increasing by 1, my cost is going to go up by $5.15. That's my slope. My slope is $5.15. Over 1 if you want, but my slope is $5.15. That's it. So what's the equation of our cost function, or our formula for the cost function? It goes like this. 5.15 times the number of gallons. And that's it. That's it. That's our cost function right there. Now you might be wondering, hey, wait a minute. Aren't straight lines supposed to have like a B there, like an X, not an X, a y-intercept? Where's the y-intercept? Well, we don't need it because the y-intercept is 0. Because if you don't buy any, you don't pay anything. The y-intercept is 0. We didn't actually need that, not for this problem anyway. So that's the main point I wanted to make was basically this one. When they say 5.15 per gallon, that's your slope. That's your slope. If X increases by 1 gallon, the Y increases by $5.15. That's your slope, 5.15. It's a beautiful thing. Beautiful thing. All right, let's look at a slightly different cost structure. Carly's Biodiesel Co-op charges $40 a month just to join up. But the benefit is you pay less, only $4.95 per gallon. You have to fork out the $40 first, but then the gas will be cheaper, or the biodiesel will be cheaper. So it says determine C of X and sketch out its graph. Well, first you pay $40 no matter what before you even get to the pump. First you pay $40 for the right to use the pump. So what's your cost going to be? It's going to start at $40. And then you're going to pay $4.95 for every gallon. Notice you take the $4.95 each and you multiply it by how many you bought. Just like going out to the grocery store. These are $4.95 each. Oh yeah, how many did you buy? I'm going to multiply the $4.95 by how many you bought. So I suppose you could say, suppose you could write it the other way if you like to see the mx plus b look right. You could write it this way, but honestly, it doesn't matter. It doesn't matter what order you add two things, right? So there it is. There's Carly's. Now, wasn't that nice? That was nice. You just think in terms of, well, first I got to pay the $40, and that's no matter what. That has nothing to do with how many gallons I buy. I just have to pay the $40. Then I can walk up to the pump and start paying $4.95 for each gallon. It works. Let's picture this. Pictures are wonderful. I love pictures. So this is X gallons going this way. This is the cost function going this way. And unlike Biff up here, where if you bought nothing, you pay nothing, this is very different. If you buy nothing, you still got to pay $40 just to be a member. So you're starting over here at $40. Then you go up as a straight line from there. So the first gallon is actually going to cost you $44.95, right? Because it's the 40 plus the $4.95. So anyway, the slope is the same, or not the same. The slope is the same idea. Over 1 gallon, up $4.95. That's your slope. I like that picture. It's a pretty cool picture. It kind of shows you, yeah, whoops. It kind of shows you, yeah, there's my y-intercept, and that's my slope. $4.95 is my slope because it's $4.95 each. But I'm starting at 40, so where you start is your y-intercept or your little b. And it's beautiful. That's beautiful. I like it. All right. As long as we're on this page, comparing Biff to Carly. Okay, so Biff was $5.15. Carly was $4.95, but you had to spend $40. Okay. Who should you buy from? Well, if I were to put Biff's, if I were to try to take this Biff line here and draw it right on top of the Carly line, right? Biff, you started by paying nothing. The problem was it was more expensive. So the slope there was $5.15, I think, right? Yeah, $5.15. So maybe I'll write this is Biff. Just to be clear, that's Biff. That's Carly. Now let's change our colors again. So you'll notice that if you're not going to buy that much, you probably want to go with Biff because his line is lower. But if you're going to buy a lot, you probably want to go with Carly because her line is lower than Biff's out here. So it kind of depends how much you're going to buy, right? Now there's this magic number here, and I'm just going to call it X question mark. There's a certain number of gallons where if you buy less than that, then you should buy from Biff. But if you buy more than that, then you should buy from Carly. So how do we figure out what number of gallons that is? What's the magic number of gallons here? Well, you can ask this question. I guess I'll ask it right down here. So when is, or where is, or I don't know what word to use there. When is Biff's price the same as Carly's price? Because if you're buying exactly this many gallons, it doesn't really matter who you go with, right? So when does that happen? When is Biff's price the same as Carly's price? Well, Biff's price was up here, 515x. So Biff's price is 515x. And when is this the same as, get it, equals, Carly's price, which is that equation there, 40 plus the 4.95x. So this expression represents how much you pay Biff for X gallons. And if you buy the same number X gallons from Carly, you're going to pay this much instead. So what you do now is you say, okay, that's an equation. I can solve it. So I'm going to subtract 495 on both sides, 495x I should say on both sides. So what is this here? This is I guess a 20 cents x. 0.20x equals $40. Now I divide both sides by the 0.20 to get the x by itself. And where are we? I believe that comes out to, what's that come out to? 200? Why am I? Yeah, 200. 200 gallons is the crossover point, if you will. So, if purchasing 200 gallons, go with Biff. Let me make sure I said that right. Check my graph again. If I'm buying less than 200 gallons, I should go with this guy, which is Biff. Right. Otherwise, or I could say if over 200, go with Carly. There's our official answer to this question. Pretty cool. So we got some nice concepts here. First of all, the idea of slope, the idea of y-intercept, and the idea of, hey, where do these lines cross? Well, just set them equal to each other. Set the functions equal to each other. When do they have the same output? Right there. Oh, that's where they cross then. And so on. All right, let's do a couple more examples. So here we are at Ollie's biodiesel outlet. He's got a slightly different kind of cost structure here. First of all, $4.80 a gallon. That's cheaper than both of them, ain't it? $4.80 a gallon. Boy, let's go to this guy's. Oh, here's the fine print. You got to read the fine print. You have to pay at least $300. Which is kind of like saying you better buy enough gas that it costs you more, or biodiesel that it costs more than $300. So, determine C of X and sketch this graph. Okay. So I'm going to, I think what I'm going to do, sometimes I prefer to sort of draw the graph first, because the graph helps me figure out what's going on. And you may find yourself doing the same thing as well. So if I, how should I say this? Without the fine print, if you didn't read the fine print, you'd be thinking, oh, I'm just paying $4.80 a gallon. Bada boom. So the slope here is 1 gallon costs $4.80. That's the slope. Okay, cool. But then all of a sudden you read the fine print and you go, oh my God, I have to pay at least $300, which means I don't know where $300 is here, but you're not going to pay less than that. So you can't possibly pay less than that, which means that we should get rid of this part here. So I think I can get rid of that by doing this. And then just redrawing this part. There we go. That's what's really going on. Now again, we've got this this magic number here. How many gallons do you have to buy before it's worth it? You don't want to spend $300 if you're not gonna, if you're only gonna get 2 gallons. You don't want to spend $300, right? So where is this magic X? We should figure this out. So when or where is the $300? Because that's the equation of this function, just y equals 300. When is that going to be the same as this one, which is just 480x? I suppose I could have taken a little time to say that first. What are you doing to me? That before, without the fine print, the cost is simply $4.80 per gallon, right? But this says this is basically cost equals 300. That's the only way you can write the equation of this blue line. It's 300. That's what the output is. It's 300. But 300 goes this way. The green line goes this way. Where do they cross? When does the 300 equal to 480x? I'm going to write this around the other way. When does the 40x, $4.80 x equal to 300? Well, you divide both sides by 480. And what you come up with pretty quick here is that 62.5 gallons is the magic number. If you buy less than 62.5 gallons, you should probably not buy it here because you're going to spend $300 no matter what. All right, let me clean up this graph so it doesn't look so gross. Gross, 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 gross. Okay. We don't want it to look gross. That's what the graph looks like. See? So you're on this kind of a horizontal plateau over here of spending $300, and then once you get past the 62.5 gallon, you start climbing up here paying $4.80 each for each additional gallon. How can we write that as an equation? Well, it's got two parts to it, right? So you're going to need two straight lines. So the first straight line over here is just the cost is $300. It's a constant function is what we call that. The cost is $300. And that's true if you buy 62.5 or less gallons, or fewer gallons, or anyway, less. If you buy 62.5 or less, you're going to pay $300. So you put this little if statement there. So you only use the 300 if the x is less than 62.5. Now, otherwise, you're going to use the other equation over here, $4.80 x. Use the $4.80 x, and you use that if x is greater than 62.5. Huh? This is what we call a piecewise. Come on, you. This is what we call a piecewise-defined function. That's French for that is. Piecewise-defined function. Why is it called piecewise? Because the domain is split into two pieces. Remember what a domain is? A domain is basically the set of all possible inputs. And the inputs are the x generally. So if your input is less than 62.5, this is what you use for your your output. Whereas if your input is anything greater than 62.5, you come over here to this formula to figure out your output. This is what we mean by a piecewise-defined function. And this happens a lot with cost structures, especially this one. All right, so I've introduced all the main ideas, I think. We're going to need to do a piecewise-defined function for this one for sure. This is a much more realistic kind of cost structure. If you ever open up your bill, oh my God, you're like your electric bill or whatever, phone bill, anything, they're going to give you all these things going on. Just try to pay your taxes sometime. You have all these things going on. So let's see. We got all these things going on. Ellie's Biodiesel Emporium uses the following cost structure. $5.20 a gallon is the base price. You get a 30-cent per gallon break if you buy more than 200 gallons. That's cool. 4 cents a gallon for a green fee, and the pump usage fee is $9.49. Okay, a lot going on there. This is a perfect example of when I would rather graph first than try to get the formula first, because a graph is like a picture, and a picture is a lot easier to understand than just swinging a lot of words around, I think. So anyway, I'm going to start with what this says. $5.20 a gallon base price. Okay, if that was the only thing going on, then this is what would happen, right? You'd have a slope of, you buy a gallon, you pay $5.20. Okay, that's, this is X gallons, this is the cost. Let's see, that takes care of that. Let's get out a new color. 30 cents a gallon, price break for the gallons purchased beyond the 200th. So actually I'm going to come to X equals 200 gallons. I'm going to stick it right there. So when you're at 200 gallons, you don't follow this line up here. You only stay on that line until you get to there. After that, it's cheaper. 30 cents a gallon cheaper. So it's got not as big of a slope there. So the line kind of bends over like this. Out here, your slope is only buy a gallon, pay, let's see, $5.20 minus 30 cents. You're going to pay $4.90 a gallon. So that's the slope out there. Okay, cool. We took into account that one. Now what? Let's do the 4 cents a gallon. How do we take that into account? Well, that means that instead of paying $5.20 a gallon, I'm going to be paying $5.24 a gallon over here. And over here, instead of paying $4.90 a gallon, I'm going to be paying $4.94 a gallon. Okay, fine print. They always got the fine print. Okay, fine, whatever. And let's see, one more. What color do I need? Let's do, okay, we'll do this one. Okay. $9.49 pump usage fee. Notice it doesn't say per gallon. It doesn't say per gallon. It just says you're going to have to pay $9.49 to walk up to the pump, I guess, or if you're going to use the pump. So what am I going to try to do? I'm going to try to make this the y-intercept. It's not at 0, it's at $9.49, which means, using the wonders of technology here, I'm going to try to, I wonder if this will work. I get the feeling that's not going to work. I'm going to do it this way. Wait a minute. Come on, you. Stop it. Yeah, wonders of technology. Yeah, what was I just saying? Okay, I'm going to see if this works. I want to try to just cut this part and lower it. Will it let me? See, it lowers the whole thing. That's not what I wanted to do. I was afraid of that. Well, how am I supposed to just cut the... How am I supposed to do that then? I guess I just have to do this then. I have to erase the whole x-axis. Erase the whole thing. That's what I have to do. So I'm basically lowering my x-axis to here. Now that's still 200 there, right? This is still the x-axis here. Okay, so now I've got a good picture. There's the cost function. So it starts at 9.49 if you buy nothing. I suppose if you want, you could label that x equals 0. It climbs at a rate of $5.24 a gallon until you get to 200 gallons, and then it's cheaper. It only rises at $4.94 a gallon. That's beautiful. That's beautiful. I'd much rather have the picture in front of me and then start trying to get the equations than to just keep using words. Words freak me out. Words are freaky. Words are way too freaky. So anyway, let's see. What color shall we work in? Let's do the brown, everyone's favorite color. So it's obvious from now that I've got basically two lines. I got two parts. It's going to be a two-piece function, piecewise defined, two parts. And what are the two parts? Well, this part here, part 1, I guess, and this is if you use less than or equal to 200 gallons, then what's your cost function? Your cost is, and we can piece this together, it's mx plus b, right? And we know what the m is. It's right there. It's the 524. So 524x. And we even know what the b is. It's right there. When x is 0, that's where we cross the axis. So I'll try to make that look like a 949. Cool. Well, that wasn't so bad. Now, let's use an even differenter color. What's happening out here? So this is if x is greater than 200. What's my cost structure here? Well, I know the slope out here too. Woohoo! I know the slope. It's 494 per gallon. Awesome city. So 494 mx plus, now here's the problem. And I want to emphasize this city with a big old hey, and maybe even a flag. Hey! You don't know what that B is. See, if I gave partial credit, you could just ignore this part of the problem, right? And say, well, I got most of it done. But you need to get the problem finished. It needs to be finished and it needs to be right. So don't just make a guess, is what I'm trying to say. You don't want to make a guess. You could end up throwing away all the work you've done so far. No good. Don't want to do that. So how are we going to get the B? First thing I want to point out, that is not your B. Why not? Well, isn't it supposed to be, go away. Okay, isn't it supposed to be that you should be able to plug in any x you want and it'll give you the right y value, right? That's supposed to be for any point on this line. I should be able to plug in the coordinates of any points on that line and the equation will work. Well, that point is not on that line, is it? This line, if you went back, it would cross over here someplace. So no, that is not the y-intercept. Don't just throw that in there. Now, let's see. Can I get rid of a lot of this stuff? I sure hope so. Let's take back most of that. Okay. In fact, let's even take back that and that. Okay, cool. So we need to use a point that's on the green line. We need a point on the green line. And since I'm talking about the green line, I'll use green. We need a point on the green this is how you spell green to get the B, to get this B. We need a point on the green line. Well, you see that point right there? We can actually figure out the coordinates of that point. And that would be good because that point is on the green line. It's also on the blue line, but who cares? It's on the green line. That's what matters. That's a point on the green line. What's its x-coordinate? Right there. Its x-coordinate is 200. What's its y-coordinate? Wouldn't we like to know? Well, I'll tell you what. Like I was just saying, it is on the blue line also, right? And we have the equation of the blue line. So I can just plug my 200 right there. The cost of buying 200 on the blue line is 5.24 times the 200 plus the 949. So the cost of buying 200 is, and I need to figure that out. So 524 times 200, 5.24 times 2, come on you, 5.24 times 200 equals, and then add a 9.49 to that equals. I got a 1057.5. 1057.49. That's a lot of money. So if you buy 200 gallons, you're going to pay $1,057.49. That's the coordinates of this point. When x is 200, y is this. Like I say, I just used the equation of the... I just used the equation of the blue line to get that, but it's also on the green line. So I can use that point over here now. So when I plug in 200 gallons plus B, I'm supposed to get, let's make that look a little bit more like a B. I'm supposed to get the 1057.49. Trying to squeeze this in here. Right, it's supposed to go through that point. Cool. So now we can get the B. So the 494 times the 200, let me see what that is. 4.94 times 200 is, that's an even $988 plus B equals the 1057.49. So I need to subtract the 988 on both sides. And so the B is, okay, minus 105. It's 69.49. 69.49. That's the B for this. That goes there. To finish my function then, I'm going to write the answer over here. The cost of this is, well, it depends. You use this Brown equation, 5.24x plus the 9.49 if x is less than or equal to 200. And then you use this equation over here, this purplish one, 4.94x plus, and I just solved for the b, 69.49. And you use that if x is greater than 200. There she blows. That's a good way to do it. So I just wanted to make a final comment before I let you loose on the homework. So I'll put the PS over here. What color should I make it? I should make it some kind of color. In fact, I'll even put it down here. PS. On the homework, when it says, where is the homework? Make sure I'm reading it exactly right. On the homework, when it says, sketch a graph showing the key features of C's structure. C is the name of the cost function, right? You can just refer to it as C. Sketch a graph showing the key features of C's structure. I am not asking for a computer-generated graph. I am not asking for something that's particularly to scale or anything. What does this mean, key features? What it means is, look what I've got on this graph up here. I've got the y-intercept. I've got the slope. I've got this elbow point. I've got this slope. I've got this. That's all. Label the x-axis and the cost axis, I suppose. That's enough. It's this. You would not be able to say this was to scale. This is 9.5 and this is 200. No, that's not to scale. I don't care about the scale. Just capture the features of the graph. That's good enough. Okay. Alrighty.